So, this is Kumar, Physics faculty, Intermediate, IIT. But today we discuss about electromagnetism. This is only pure for 10th class and also it is useful for second year students, intermediate also. ఇది ఎలక్ట్రోమాగ్నెటిజం మనం డిస్కస్ చేస్తున్నాం 10th క్లాస్ వాళ్ళకి పబ్లిక్ ఎగ్జామ్స్ కోసం. ఇది సెకండ్ ఇయర్ వాళ్ళకి కూడా కొంతవరకు యూజ్ అవుతుంది, కొంతవరకు కాదు మ్యాక్సిమం ఉంటుంది. మనం ఇది పబ్లిక్ ఎగ్జామ్స్కి యూజ్ చేస్తున్నాం. దిస్ ఈజ్ నాట్ ఆబ్జెక్టివ్ టైప్. ఆబ్జెక్టివ్ మళ్ళీ మనం ఇంకో రోజు సమ్మర్ హాలిడేస్లో మనం డిస్కస్ చేద్దాం. ఓన్లీ ఇంటర్మీడియట్ ఆబ్జెక్టివే చెప్తాను, ఓన్లీ ఇంటర్మీడియట్ ఆబ్జెక్ట్. ఫస్ట్ ఇయర్ మీరు అప్కమింగ్ ఫస్ట్ ఇయర్ కాబట్టి 10th క్లాస్ వాళ్ళందరూ సమ్మర్లో ఫ్రీ వీడియోస్ చేస్తాను మీకు. ఓన్లీ ఇంటర్మీడియట్ ఫస్ట్ ఇయర్ ఆబ్జెక్టివ్, ఓన్లీ ఆబ్జెక్టివ్ అండ్ ఇంటర్మీడియట్ ఐపీ కూడా చెప్తాను. సరే, ముందు we discuss about electromagnetism. What is electromagnetism? The electric and magnetic fields both are perpendicular to each other. The electric and magnetic fields both are perpendicular to each other. That is not electromagnetism. We know the electric and magnetic fields are perpendicular to each other. Suppose consider a magnetic needle. This is the magnetic needle. The magnetic needle having north pole and south pole. Every magnet is influenced by another magnet or iron piece. Every magnet is influenced by another magnet or iron piece. The magnet is influenced by another magnet or an iron piece. This is also magnetic needle. This is the magnetic needle. Now let the magnetic needle, this is not influenced. Why? Because there is no magnet, there is no iron. There is no magnet, there is no iron. But the magnetic needle made no deflections. Made no deflections because there is no iron or magnet. Iron or magnet. Simple. The magnetic needle doesn't made no deflections because there is no iron. Nearer to the iron, there is no iron or magnet nearer to it. Nearer to it. Simple. Suppose according to iron, suppose iron or magnet nearer to it. Suppose for example, let a wire, the wire carries the current. The current I is passes through the wire when it is connected to a battery, when it is connected to a cell. The wire which is connected to a cell, then the current is passes through it. Then the current is passes through it. Simple. So let consider the current is passes through the wire. Then the magnetic needle made the deflections. If the current is passes through the wire, then the magnetic needle made the deflections. How it is possible? That is explained by Xth in 19th century. Xth experiment. What is Xth experiment? Let a magnetic needle nearer the wire or conductor which carries the current. Let a magnetic needle which is nearer to the conductor which carries the current. Then the magnetic needle made the deflections. How it is possible? Because only the magnetic field is developed perpendicular to the direction of the current. The magnetic field which is developed, it is represented by letter B. The magnetic needle which is developed due to the current passes through the wire perpendicularly. The magnetic field is always perpendicular to the magnetic field is always perpendicular to the current which is passes through the wire. Due to this field, the magnetic needle is influenced. So it made the deflections. So this is called Oersted experiment. Simply. The magnetic needle which is brought nearer to the conductor which carries current, then it made the deflections. How it is possible? Only because due to the current passes through the wire perpendicularly, magnetic field is developed. This influenced the magnetic needle, so it made the deflection. What is the direction of the deflection? What is the direction of the deflection? By using Ampere's swimming rule. What is Ampere's swimming rule? Simply, this is the wire which carries current I. There is a magnetic needle having north and south poles. Let assume that a swimmer, for example, this is a swimming pool. A swimmer swimming in a pool. Assume that the current passes through the wire nearer to the magnetic needle. This is the magnetic needle. Assume a swimmer swimming in a swimming pool. If the current passes through this wire, the magnetic needle of the north pole deflects like this direction. That direction means it represents the swimmer swimming in a pool is left hand. This is the left hand. So the north pole of the magnetic needle deflects towards the left hand of the swimmer. Simple. This is the current passes through the wire which is brought nearer to the magnetic needle. Consider a swimmer swimming in a pool. So the swimmer, this is the left hand of the swimmer. This is the left hand. So the magnetic needle of the north pole deflects towards the left hand of the swimmer. This is Ampere's swimming rule. Simply, suppose a man swimming along the direction of the wire. Suppose a man is swimming along the wire in the direction of current facing magnetic needle, then the north pole of the magnetic needle deflects towards the left hand of the swimmer. This is called the Ampere's swimming rule.